Alright, so here we're going to look at the 4.1, 4.2 quiz to get you guys ready for a retake. First part is describe how each function was translated. All this is looking at vertex form and then looking if we have an h value or a k value. H value tells if we move left or right. We have to think opposite on that because of the subtraction sign in front of the h. And then k tells us how many units we move up or down. So looking at this one, this 4 is not in the parentheses with the x. So this is a vertical shift, which means it's moving up or down. So vertical shift up 4. It would take the regular parabola shape and move it up 4 units. This one here, I see the 3 inside the parentheses. And it looks like a -3, which would make us want to say to the left, but we have to think opposites on this. So this is a horizontal shift to the right 3. Horizontal shift right 3. Alright, so next part, state the vertex, min, max, axis of symmetry, and domain and range for this function here. Now, for the vertex, all it's going to be is our h and k values. I have to think opposite of this -1. So it is 1, 4. Alright, the axis of symmetry is always x is equal to the x coordinate of your vertex. Don't forget that x is equal to, though. You have to have that because that's what tells us it's a line on the graph. And that's the dotted line that would pass through our vertex. So if we're just going to think of this quickly as a sketch on an xy plane, our vertex of 1 and 4 would be right here. That axis of symmetry, that x is equal to 1, would be this vertical line that's dotted that allows our parabola to be symmetrical. Now, with this, taking a look at our a value. Our a value here is a +2. That means my parabola opens up. This is just a sketch to help us visualize. That makes our vertex a minimum, right? Because that vertex 1, 4 is the lowest point our parabola will ever go. Domain is all the possible x values this parabola will ever be allowed to go to. And notice the arrows on the ends of the lines. That's going to tell us it's branching off forever to the right and forever to the left. That's what makes our domain all real numbers. We can have any x coordinate and plug it into this function. Now the range is always different for each parabola. It involves the vertex. Remember, here's your setup, talking about our y values, and it's going to be in between our lower bound and our upper bound. So the smallest that we ever get is our vertex in this case because it's a minimum and it's a 1. Right? And I'm going to put a line under that inequality because I'm allowed to actually be 1. Here we are at that point, right there. Now in terms of how far up this parabola will go, it travels up forever. So that'll be positive infinity with no line under that inequality because you can't be equal to infinity. Okay? So number 4, using 2 points, write an equation for the following graph in vertex form. Here is that vertex form. Here's the 2 coordinate points they give us. They gave us our vertex of, you can look at the graph to find this, -3, -1. And then they give us another point, and that other point is at -2, 1. Okay? Alright, so here's how we can do this. We're going to take our vertex and plug it into our vertex form. So that's going to tell us our h and our k value. So here's what that would look like. We have y is equal to, I still don't know a. I've got x. Now when I do a minus a -3 here, that's going to turn into a +3 because it's got to look like the opposite. And then we have -1, therefore our k value. So this is us just plugging in our h and k values. Now, how I'm going to be able to use this other coordinate point is I'm going to use this -2 as an x value, this 1 as a y value, and plug those in to my equation. Alright, so now instead of having this x here and this y here, I can plug in that x and y coordinate, which the x was a -2, the y was a 1, Now you may see that the only variable we're missing is a. We're going to be able to solve for that mathematically. So here's how we would do it. We've got negative 2 plus 3 is 1. 1 squared gives me 1, so I've got 1a, because all this eventually multiplies by a. 1a, and then this minus 1 is equal to 1. Add 1 to both sides. Add 1 to both sides. And we would get that 2 is equal to our a. So now we know a. We already knew h and k. H was a negative 3. K was a negative 1. Now I can input all of those into my final form. So we'd have y is equal to, my a is 2, x minus a negative 3, and then minus 1. So when we're given a vertex, all we really need to find is that a value. And we find that a value by plugging in the other coordinate point and then solving for a. We also talked about here in class about using the graph as a guide. We talked about the relationship between when I go over 1 and up 2 here. That would also tell me that my a value is 2. But that's not as sound as doing it mathematically. And the mathematical way will help us, especially when a is a fraction or a really large number, or if we don't have a graph to kind of look at that concept. So this is definitely the safe way to do it. Plug in your vertex, plug in your other coordinate point, and solve for a. Okay, so let's go ahead and move on to the next one. So let's start to answer these questions. This equation is given to us in standard form, which means if I want to find my vertex, the x-coordinate comes from negative b over 2a. We need to calculate that. And here's our a, b, and c values. Here's my a, here's my b, here is my c. So b is going to be a negative 12. All right, so I'll put in that negative 12. Our a value was a 2. So we'll get a positive 12 over a 4. This tells me that the x-coordinate of my vertex is a 3. All right, that also tells me our axis of symmetry is x is equal to that 3. Now to find the vertex, I need to take that x-coordinate and plug it back into the original equation. That's how we find any y-coordinate given an x, even with linear equations or whatever. So we're plugging in a 3 here. So we get 3 squared is 9 times 2, so we get an 18, minus a 36, plus 3. Put all those together and we will get a negative 15. All right, so there is our vertex at 3, negative 15. All right, and we also know that that axis of symmetry is going to be that dotted line that makes our parabola symmetrical. Okay, now something that's nice about standard form. Y-intercept, it's always 0, something, and it's always 0, c value, the number on the end. Here's how that's going to help us. I've got a y-intercept here on 3. So since this is symmetrical, it's 3 spots away from our axis of symmetry. So 3 spots away from our axis of symmetry on the other side will tell me another coordinate point. And looking at this, we know our parabola is going to open up because there's our vertex in red. Now the parabola is opening up, making that vertex a minimum. Actually, our parabola is going to open up. Now, it says calculate or use parent function knowledge to have 5 points on your graph. A couple ways of doing that. One way is to make a table. We know our vertex is 3, negative 15. So to find some other coordinate points, I could either plug in 2 or 4. These will both give me the same answer because they're on either side of the vertex. I could plug in those values there into the original equation. All right, so plugging in either 2 or 4 would tell me those points. So that's another way to generate 2 points. It's also possible just to understand the parent function of how parabolas change. Right, a regular parabola will go over 1, up 1. But now, since our a value is 2, it doubles that growth. So now as we go over 1, we will go up 2. So I can do that from my vertex here, over 1 up 2, to give me this point here and here. And if you plugged in either 2 or 4 into the original equation, you would get negative 13 for both. Okay? So that's one way you could plug those in, or use the curve method. So other points you could have done 1 and 5 if you wanted, any other points that you could calculate to find that would work. All right, and then we can get our parabola in there. All right. Convert the following to vertex form, which you need to have memorized. That's going to be our y is equal to a times x minus h squared plus k. Now, what we need to do on this is we need to locate our vertex, because our vertex will tell us our h and k value. A is shared between both standard form and vertex form. So in terms of my final answer on this one, I know that my a value is an invisible 1. All right, so I can either put a 1 here, or you wouldn't have to. I can jump right into my equation. So we find our vertex using our negative b over 2a. Our b value is a negative 8. Our a value is a 1, so we've got 8 over 2. 8 over 2. To get that our x-coordinate of our vertex is 4. So that's our h value. I can go ahead and bring that on down. Now to find the y value, so to find the number that goes here on the outside, it will not be any of these numbers. It's never going to be those numbers. The only way to find that k value is to plug in their x-coordinate, the vertex, into the equation. So let's do that. All right, so going back to our original equation. We've got x squared minus 8x plus 19, and we're plugging in a 4. So we'll get 16 minus 32 plus 19. You put all those together, and you will get a positive 3. All right, because our vertex for this one was 4, 3. All right, let's try to get on this one. We need to locate the vertex. We're going negative b over 2a. b is 6. a is 3. So I've got negative 6 over 6. Tell me the x-coordinate of our vertex is a negative 1. So in terms of our vertex, I've got negative 1, comma. Now to find the y-coordinate, we need to plug that negative 1 back into our equation. So we got negative 1 here and here. Negative 1 squared is 1 times 3 is 3, minus 6, minus 4. Put all those together, and we'll get that the y-coordinate, to where the y-coordinate of our vertex will be a negative 7. So if we put that negative 7 in here, that's going to finish off our vertex, to where this once again is our h value, this is our k. The a value is shared back from that original equation here of 3. So this a is also here of 3. So when I go now to write that final equation, we have y is equal to a, which is 3. And then x minus h, so minus a negative 1, will turn positive squared, and then minus 7. Now, something that people mess up on quite often is that they think that some of these numbers will show up in vertex form, which they won't. Notice that those are definitely different. A does show up. A is shared amongst both, but that's it. So neither the h or the k value are going to share any of this 6x or minus 4 stuff. A is the only shared value between those two equations. This 1 and negative 7 came from the vertex, not any of the numbers in the original equation.